Okay, so class, we're going to go over 5.4 today. We're going over standard form. Now, there are multiple ways of writing standard form because standard form is written ax plus by equals c, where a, b, and c are real numbers, okay? And two rules, a and b are not 0. Okay? So those are our rules. This is how we're going to look at it. Okay, 2x minus 6y equals 4. Give two examples of this equation that are equivalent, but not like written the same way exactly. So you can multiply this by different numbers. So in the book, they multiply this by 2 or by 0.5. Let's say we multiplied this all by 3. So every part by 3. So this by 3, this by 3, this by 3. This would become 6x, so we times by 3. 6x minus 18y equals to 12. Okay, so this equation right here is equal. Okay, these two are equal. What if we multiplied it by 0.5? We would get x minus 3y equals to 2. This is equal to this, okay? These three equations are all the same. They're just variations in terms of what you multiplied by. You call that a scalar multiple, okay? So, variations happen, but it's in appearance. It's not necessarily the substance of it. Okay, write the equation in standard form for the lines shown. Okay, so first thing, we have 2 points. We're going to write this in standard form. I'm going to show you the process. Okay, the process is, first we find our slope. So I'm just going to subtract this, so 1 minus negative 2 over 1 minus 2. This becomes 3 over negative 1, or negative 3. Okay? Now, we could plug it in as point slope, so I'm just going to do that with this one right here. So we get y minus 1 times x minus 1. Y minus 1 equals negative 3, x minus 1. So distribute, so you get y minus 1 equals negative 3x plus 3. We're going to get our 1 over there. And we're going to move over our variables. So all our variables are going to be on one side. So we're going to add 3x to this side. So we get 3x plus y equals 4. This is standard form, okay? So we move from slope-intercept right up here to standard form by moving our x over, okay? That's all you've got to do in this class. Okay, so you got to move it over, okay? So let's try another problem. Okay, yeah. Okay, we have the points 3 comma negative 1, 2 comma negative 3. We're going to make this into standard form. So first thing we need to do is find slope. Slope is going to be negative 1 minus negative 3 over 3 minus 2. Does it matter which one you choose to go first? No, but you've got to stay consistent, okay? So this is going to be positive 2 because 1 plus 3 is, negative 1 plus 3 is going to be 2. And 3 minus 1 is going to be 1. So it's going to give us a 2. Okay, we can choose whichever point we want to do. For purpose sake, I'm going to choose this one up here. So y minus negative 1 equals 2, x minus 3. I'm going to distribute, so we're going to get y plus 1 equals 2x minus 6. Subtract the 1 from both sides. So you get y equals 2x minus 7. That's our slope-intercept. Then we're going to subtract 2x from both sides. So we get negative 2x plus y equals negative 7. Okay? That is going to be our answer. Okay? So, remember, standard form, x and y are going to be on the same side, and the y-intercept is going to be on the other side by itself. Okay, it's not necessarily the y-intercept, but it's approximate. It's similar enough. Okay. Horizontal, vertical line. Okay? Horizontal line. Line is going to be the equation y equals a number. A is any real number. Okay? This is horizontal line. So what is vertical line? If horizontal line is y equals, then vertical line is x equals some number. Okay, any real number. Okay, so y equals a number, that is a horizontal line. X equals is vertical line. Now, let's have a hypothetical. Hypothetically, we have a line. Okay? Sorry, this is our y, this is our x. Let's say this line passes through the point 3, 4. Okay? Let's say we have a vertical line right here that passes through the points negative 5, negative 3. Okay, what's our equation for this line right here? Secret is this is a horizontal, so we immediately go to y equals. Okay, so y equals what? Well, which one of these is our y? Is 3 or is 4? In this case, it's 4. So all you do is just use the y in the y value. Okay, so y equals 4. Okay, that is our equation for this line. What about this one? This is a vertical, so x equals. So we say x equals. Now, which one is our x? Negative 5 or negative 3? Negative 5. So x equals negative 5. So our two equations are y equals 4 and x equals negative 5. Okay? Very simple way of doing it. You can do this. Okay? Okay? Does it matter where this point is? No, if this point was along this line, this vertical line, it would always be the same equation of the line. Okay? If this point was anywhere moved, it wouldn't change. If it was moved horizontally, it wouldn't affect this equation. Okay? The equation is consistent no matter what point you choose along the line. Okay? Okay, so that's horizontal and vertical lines. Now those are crucial. These are simple answers to the question, but it can get more complex, okay? Finding the missing coefficient, let's see how important this is for today. You know what? I think we can skip that. We do not need it for today. Okay. We may cover this next class period, but bear in mind it isn't crucial. The one that might be useful is this equation up here. But again, we'll talk about it. So, we'll leave this as what it is. We're not going to do example 4 on the book. So if you do example 4, you're doing extra work. I am going to talk about the extra credit for class today, okay? I will see you guys shortly. Bye.